Hi, so I was doing a bit of clearing up recently and I came across this. This is actually the first prototype board of the first thing I ever got paid to design. This is a printer buffer. Now, the youngsters amongst you probably won't have a clue what that is and why you might need it. You need to take yourselves back to the mid-1980s when people were using home computers with 16 or 32k of RAM, non-multitasking operating systems, and dot matrix or daisy wheel printers which were rated in terms of lines per minute and not pages per minute. What this provides is basically an external memory to store data that you send to the printer, because on these old systems, if you want to say print a multi-page document, you'd hit print, it would start sending data to your slow matrix printer, and it would tie the computer up for most of the time until the thing had finished printing. So this could be tens of minutes or even longer with things like daisy wheel printers. Printers typically came with very little memory. Memory was really expensive in those days, so your printer might have, perhaps 2k of memory if you're lucky enough to maybe buffer one or two lines, and your computer might have just a very small amount of buffer for its printer output. And of course, we'd be talking about running things off floppy disks or even tapes, so you wouldn't be able to buffer these things onto a hard disk or anything luxurious like that. So the idea behind this is you just plug this in series with your parallel printer cable, and when you hit print, it will basically act like a printer that's got a very large buffer. In this case, this could take up to 256 kbytes, so your computer would just stream all the data out to this. You then free your computer up so you can then do other things while your printer's happily chugging away printing stuff. So this is the first sort of prototype with a sort of hand-etched PCB. This is what the production board looked like. I haven't actually got a complete unit. I actually found this, I think, at a radio rally or something like that, just as a bare board. So I just grabbed it as a bit of my history. I found a couple of pictures online of the production cased version, and so the hardware is fairly simple. It's based on this. This is the Rockwell R6511Q. This was a very early microcontroller. Around this time, your typical chipset was like a processor, an external memory, external I/O ports. So any processor, you had to add quite a lot to it to actually make it do anything at all. This incorporated a 6502 processor core with a few additions for I/O operations like bit set, bit clear type operations on I/O ports, just to speed up bit I/O operations. It had 192 bytes of RAM, because of course on a lot of small applications you don't need much RAM, but you do need some, and your typical processor chips of that day had none at all. And some I/O ports. And this came in a couple of versions. There was a version that had mask ROM, I think up to 4K of mask ROM, and this version which could run an external EEPROM. This is an 8KB EEPROM. And this uses 256K by 1 dynamic RAMs. And these old devices were relatively simple to interface to. They had a multiplexed address bus, and you basically sent a row address, strobed the row signal, sent the column address, then strobed the column signal, and then you'd read or write that particular location. They also needed refreshing by just sort of accessing every row periodically to keep the memory contents. Now, the way that I handled this, you see there's very little external hardware, much less than you'd see in things like the early home computers that used dynamic RAM. Because this was being used as a buffer, not as like main program RAM or anything, I was actually effectively bit bashing the access to this, so that the address space, I think the address space was probably split up into probably 3 or 4 regions. There's a 74LS139 decoder here, so the memories of this are getting a little bit foggy because it was I think 1986. So addressing one memory area would set the row address. The row address bits are connected directly to the address pins of the RAM, so you'd access one area to select the row, you'd then access a second area to select the column, so that the RAM access was all basically software controlled, and there was a software refresh task. And because this memory was so expensive, I don't think it was ever actually sold in this version, but this was capable of having 1, 2, 4 or all 8 RAM chips fitted, and the software would detect what was fitted, and if for example there's only 2 RAM chips fitted, it would store 2 bits at a time to give a reduced amount of memory for a low cost. But I think by the time this went into production, I think the RAM costs had dropped. It wasn't worth doing a sort of a lower RAM version, so I think this was always sold as a 256K version as far as I remember. Now, I don't remember whether I did the board layout for this. I think what I might have done is just sketched out a rough board layout in a sort of CAD package, maybe even something like the BBC's BitStick system, which is a very early vector-based CAD system. And I think the actual final board layout may have been done by my customer. This was made by Watford Electronics. I did design quite a lot of hardware for them back in the days of the particularly the Acorn ARM systems, the Archimedes series. But this was the first thing I ever did with them, and so the first thing I ever got paid for. And I've still got memories of coming back on the train, holding a piece of paper, sort of contract that said how much they were paying me for this, which I think it was something like about £2,000, which I was still a student, and that was like a huge amount of money for me in those days. As well as the simple buffer mode, this had various other features. For example, you could just make it bypass, you can make it just absorb characters. So for example, if you realise the printout was wrong, you could just flick it to a mode where it would just absorb all the characters and not print them. It also had a few different hex dump modes, which is really handy if you're trying to develop a printer driver. You could actually do a hex dump of all the stuff that was coming out of the printer port. It also had a multi-copy mode where you could print a whole job to it, and as long as that job fitted in the memory, then you could press a button and it would just reprint that same job, so you could do multiple copies. And again, on a dot matrix printer, that would have been a really tedious task to do, whereas this, you could just send it out to the buffer and it would just get on with it quite happily. I found an old price list showing this was sold at £149, which I think that would have been around 1986-ish. I've no idea how many they sold. I just sort of basically got a one-off payment for the design rather than royalties. The only thing's not on this board, there's a 5-volt regulator missing here, and so I found this, found a picture online of the completed unit. So there's like an aluminium heatsink over here, and there's 3 LEDs that were mounted on the board here, and there's a switch here that was just wired to a rotary switch, which selected the various modes, and a couple of buttons. There's a reset button and a button for doing repeat prints. So this board would have been home etched, and this would have been done using tapes. Now, again, this is, if you look at old pieces of equipment, you'll often see these sort of nice sort of curvy, wavy shaped tracks. And the way this was done, again, bear in mind this is when any sort of CAD system would have been totally unaffordable. And I actually found some of these tapes in the bottom of a drawer somewhere. So basically this is like a sort of, I'm not sure what it's actually made of. It's like a paper-like tape, but it's got a sort of rough surface. So you'd typically do this actually paper. You normally do this on a translucent drafting film, so that once you've done it, you can then photo reduce it. Or the boards, most professional boards are generally done at 2 times actual scale and then reduced photographically. But you could use the same technique to do stuff at 1:1 onto drafting film or tracing paper to then stick on a UV box to use with UV coated boards, and that's how this board would have been done. And this stuff sort of came in various widths, and the technique is basically you sort of start a track. You might sort of start it like that and perhaps use a scalpel just to trim the start. This stuff isn't very sticky anymore, it's quite old, and you just sort of put it under your finger and you can then guide it round using your finger. Obviously this took a little bit of practice. I haven't done this for many years. And then again, you could use a scalpel, and you could use sort of tweezers to sort of move it a little bit, but also you could, if you had to change it, you could then like peel off, for example, if you did that, you could just peel it back off, redo it, and you can move, if you need to insert a track, you can peel it off and redo it. And there were also you could get pads. I think from memory the circular pads just came on a roll, which was split, so you could sort of plop them down manually. But you could also get rub down transfers. Some of the older amongst you might remember things like Letraset, which is like a sheet of symbols where you can sort of rub it down with a pencil, and you could get those transfer sheets with all the dip patterns, just lines of pads, and all the various sort of standard patterns where you want to keep the accuracy correct. So all these pads would have been done like that, and then the tape used to actually link them. And the code for this, obviously this was all done in assembler. This would have been done on my old BBC Micro, which is a 6502 based, very popular in the UK, 6502 based home computer system. And one unusual feature about that is its BASIC had a built-in assembler, so you could actually use it as a very powerful macro assembler. So as well as having chunks of assembly, you had access to the full BASIC language to do things with that code, to do things like conditional assembly and sort of really complicated stuff. And one of the handy things on this, and you notice that all the tracks between the processor and the EEPROM are all sort of nice and straight. The reason for that is that to make the PCB easy, I juggled around all the address lines and the data lines to the EEPROM. So part of the source code was a chunk of BASIC, which then took the assembled code and then rejuggled all the memory locations, so it sort of shuffled it around to actually compensate for this. So it meant I could have a nice simple PCB layout. Again, if you look on the production board, you can see that's just literally very simple, going straight across the nearest convenient pin, and then all the code in here is all just completely shuffled up to make the processor read it correctly. And of course on the RAM, the addresses don't matter at all, because it's RAM, you know, wherever it goes in, it's going to come out the same place. So those, again, were just routed to the nearest convenient point. I think this was actually pretty much the only prototype before we went to a production board. There's a few little bodges and mods here and there, but the certainly the chip count looks the same. We've just got so we've got the 6511Q processor, the EEPROM, the RAMs. There's a LS04 which had the oscillator made from a few gates. It's possible that some of the other gates were used. I don't remember. I can't find a schematic for this. Obviously that would have been hand drawn on paper. There's an LS139 which would be the address decoder that segments the memory map into the EEPROM, the row area and the column area of the RAM. And there's an LS74. I think that might have been just to generate the probably latch the row address and hold the row line low when that area of memory was addressed, and then the second address for the column would have probably released that row on the rising edge of the column I'd select. I don't remember exactly, but yeah, so an interesting bit of my history. Of course, these are the days when getting PCBs made was really expensive, so pretty much the only thing available to someone working at home is sort of this hand draw and and sort of home etched PCB technique, which worked pretty well. I mean, you can see the actual track quality is pretty good. I don't remember offhand how small you could get these tracks, but you could certainly get them small enough to get in between the pins of a DIP package relatively easily.